everybody, and welcome to VMware's vForum 2021. It's brought to you live here from the home office. I'm Thomas Hagedorn, and I'm here together with Henrik Mønster, and we're delighted to host this multi-cloud service mobility session for you.
Yeah, thank you, Thomas, and hello, everyone. I'm Henrik, like Thomas said, and in this session, we'll focus on multi-cloud service mobility, which it's a pretty big deal for us and a key part of the overall VMware strategy in enabling our customers who might not be born into a cloud-native data center world or application world, so to say, to help them onboard their cloud journey and start modernizing their application landscape.
Yeah, and to begin with, we'll actually be kicking off with a quick keynote from our Nordic manager, Gustafsson, together with Camilla Skallerup, which is our VMware Cloud Sales Specialist here in the Nordics. And by that, we will follow with a technical demo session, which we have prepared for you in the best TV kitchen style. So some of it is pre-done. And the demo will give you a very realistic walkthrough of how a multi-cloud service mobility can look like. Then we'll hear from one of our Nordic customers, Schibsted in Norway, and their cloud architect on how and why they use VMware Cloud on AWS to achieve their business goals. And lastly, we'll finish off with a broader panel discussion. So if you have any questions during the session, please paste the question or type it into the Zoom chat, the Q&A, and then we will either address it directly there during the session or in the Q&A panel session at the end.
Right, so thank you, Thomas. We have a pretty packed agenda to get through over the next hour, so without further ado, let's hand it over to Per and Camilla. Run the video, please.
Hello and welcome to vForum 2021. My name is Per Gustafsson. I am responsible for our business in the Nordic and the Baltic region. With me today, I have my colleague Camilla from Denmark. Please say hello, Camilla, and introduce yourself.
Hello, everyone. Yes, I'm happy to attend the vForum, and my name is Camilla Skallerup. I work every day with the VMware Cloud on AWS. But this is becoming like more and more the multi-cloud world. So that is a lot of the things that we're happening in my job.
Yeah, it's definitely a multi-cloud journey that all our customers are in the middle of. And the complexity is increasing because it's not just a decision about on-prem workloads and native cloud providers. It's about security, network governance, development model, operating models. So there's a lot to it. And I know that VMware has done a number of studies to gain customer insights. Can you share a few of those, Camilla?
Yes, we have looked into this and trying to get a clearer and more concrete view of the cloud strategies that our customers have. And we've been looking into around 1,200 organizations and asking them about their priorities and how they're building their businesses for the future and some of the biggest challenges that they're facing. And from the study, we actually learned that about 97% say that they have already adopted a multi-cloud strategy. And one of the interesting things in the research shows that many of these customers, they're living in this already in also using mission critical applications in the cloud. And that means, that it's applications that are driving revenue and operations and efficiency. So multi-cloud is definitely a business priority. As the study also shows, the cloud is driving new priorities for enterprise app. And it's all part of a larger shift in applications driven by this need to create a lot of new services and it's order to advance the digital transformation. And COVID-19 has put an extra pressure here on that transformation. So cloud native principles, containers, Kubernetes, microservices, all of this is redefining how applications are built, run, and managed. And one of the key insights to these figures is even though as significant it is to build new apps and new services, organizations, they need to create value. And when they're in this situation, they also have they're under a lot of pressure, you might say, because they have to address the reliability, the security, and the performance of their platforms as well.
Yeah, so that makes sense, Camilla, and I see that our customer are a little bit challenged at the time because they need to focus on supporting the business and the business development with all the new cloud services and cloud technology, but at the same time, as you said, manage risk, security, cost, and complexity. So a operating model that works across clouds is key. And how can we from VMware help our customer in this area, Camilla?
Well, when customers engage with VMware to help them architect their multi-cloud environment, the first thing they look at is the unification of their infrastructure. They want to normalize it and unite their infrastructure. They want to have the same compute, storage, and network stack across all of their cloud providers and that they're leveraging. And it actually brings a lot of value, not only to the IT operator, but also to the application developer. And it can reduce their costs dramatically. The second area that they look at is how we can support any application. And that's also whether it's traditional or cloud native. They want to empower their developers, and we have to support both VMs and containers. And not only that, they have to be able to expose the infrastructure to the developers so they can use their native modern APIs that they're using, like Kubernetes APIs. So they want to have these capabilities anywhere across their infrastructure. The third element that we often hear around and we talk to our customers about is unifying management, operation, and automation. And this is actually a really big requirement. Whilst they're embracing the multi-cloud world, they find themselves with a nest of providers for management and operations. And these providers, they do bring a lot of value to specific nodes of their infrastructure, but they want to look at this as a connected architecture. And they want to drive these efficiencies in their processes and using the tooling and technology that they have, and of course, utilizing the talent that they already have in-house. The fourth element that we are seeing is that because they want to unify their cloud services as well. And it's not to one specific cloud service. They have individual clouds and on-premise and edge location. And they want to be able to unify all of these. So it could be IT services such as disaster recovery and developers who have built something for the businesses to consume. They need to be able to have these incorporated to their full architecture and to their full platform.
Thank you, Camilla. And VMware has a long history in creating complex environments easy and simplified. Since 2012, we have worked very focused to create workload mobility across VMware stacks. And today we are proud to say that all the major hyperscalers host the VMware cloud stack on-prem. All the major system integrators, VMware Managed Cloud. We have been driving the modernization of on-prem environment into cloud platforms to create a application mobility across VMware stack. We are able to do so with a consistent way of running the infrastructure, running the management of application, development of application. And all of this is to address the complexity that can occur in the multi-cloud environment. Camilla, in the upcoming session where we go deeper into these different aspects, what can our audience expect?
Yes, as you might say that we often present a lot of capabilities in terms of VMware new technology, but this time we actually try to focus on real examples. So we will be looking at how to identify group dependencies on application level and how to migrate to the cloud, which tools to use there, and looking at how to manage multi-tier services and service mobility. So those are things we will be looking at today.
All right. Thank you for joining me, Camilla. And I wish all of you a good session and stay safe until we see each other again. Bye-bye.
Bye-bye.
All right.
All right, thank you to Per and Camilla for setting the stage on a business as well as strategical level. So, like I said before, we are busy. Let's move on, Thomas.
Yeah. Next up is the technical demo session, where I know Henrik has done a great job in including as much detail as possible. So you need to hang on to the coffee now and remember to ask your questions in the Q&A. Also remember, of course, the session is going to be recorded, so you don't have to worry about missing a few details just now. So let's hand it over to Henrik, which will walk us through the multi-cloud service mobility demo. Run video.
So, welcome to this vForum Online 2021 session about multi-cloud and service mobility. Today, we're going to show you an example on how to identify and migrate a multi-tier application between, could be an on-premises environment and a cloud-based environment such as VMware Cloud on AWS or other VMware-based public clouds. So the multi-cloud term or hybrid cloud term that I'm going to focus on today is about the ability to migrate applications, services between different physical on-premises environments from a local data center to public cloud, or from local data center, legacy environment, legacy vSphere environment to modernized software-defined data center, still running in your own local data center. So there are many use cases for migrating workloads between different VMware-based environments. So migrating, upgrading, replatforming, rebalancing loads, starting up on a cloud journey from a legacy on-premises environment to software-defined data center running in AWS data centers, and so on. There are many use cases. So I'm going to show you, throughout the duration of this presentation, I'm going to show you a number of small demo sequences of an environment I sat down and configured in preparation for this presentation. The application that I'm going to migrate is a 3-tier application. If you have been running a number of VMworld hands-on labs, you might be familiar with that application. It's also documented publicly, so you can build it yourself if you have a use case for your own test environment or whatever you might be running at home. So it consists of a number of web servers. I have 3 web servers in my example here today, communicating with an application server that communicates with a database server. So pretty much a traditional 3-tier application. The infrastructure environment that we are running this application on consists of an on-premises environment. It has traditional ESXi host, a vSphere environment. It has a VLAN-backed physical network. It also has NSXT installed that we're using for our, you can say, our workload domain. So where we have a more dynamic change in number of applications and so on, that they are typically running on overlay networks in NSXT. And we are consuming traditional array-based storage in this environment. Networking wise, as you can see here on this schematics, the perimeter firewall is a physical based router with firewall capabilities as well. And behind that one, we have our NSXT environment with 2 layers of routing. We have our 3-tier application, 5 VMs in total, running on an overlay network called HCX migration. Is running on an overlay NSXT segment, as we call it. And on the cloud side, we have a pretty traditional VMware Cloud on AWS SDDC. And as you can see already now, we have deployed HCX, but more about HCX later on in this presentation. So I just want to take you for a quick tour around our environment. As you can see here in our on-premises environment, we have 5 VMs, 3 web frontends, and an application server and a database server. And it's running a pretty simple application. It just more or less pulls some data out of the database and presents that in a web form, you can say. In order to generate some traffic for our management components, in this case we realize Network Insights, I have set up a small script that it basically just makes a curl, runs curl command against the 3 different web servers, so we generate some traffic that we realize Network Insight can pick up. We have NSXT running in the on-premises environment, and as you saw before in the schematics, those 5 VMs of that the application consists of is running on an NSXT-based overlay network called HCX Migration. That's connected to a tier 1 router, which is again connected to a tier 0 router that's connected to the physical router. We have VMware Cloud and AWS SDDC, and it's connected with 2 VPNs, one to the on-premises environment and one to the environment, where I'm located physically today. I'm not located on premises, so I have 2 VPN connections established. So a bit about vRealize Network Insights and how we can use that to identify dependencies between the different tiers in our application. So vRealize Network Insights it's basically your Swiss Army knife for everything networking. It will give you visibility across applications and help you in the security planning when using NSX. It gives you visibility if you're using VMware SD-WAN by VeloCloud. It can give you visibility right down to the Kubernetes pods and containers, and it can give you full stack visibility across physical and logical networking in your cloud foundation stack or in your software-defined data center. And it can give you visibility across cloud native networks such as in AWS or Microsoft Azure. So vRealize Network Insights is able to aid you in discovering your application dependencies, or just your applications in general. And it has several ways of organizing your application. It could be based on security tags, naming convention, input from your CMDB, such as ServiceNow, or if you're running vRealize Network Insight Cloud currently, you will be able to use machine learning to identify your application boundaries and dependency between the different tiers in your application and so on. So vRealize Network Insight originally was used mostly, or that was our initial use case when we acquired the technology to let's do an assessment of our current environment. Let's see which VMs communicate with which VMs and on which ports and so on they're communicating. Maybe you want to deploy NSX data center for microsegmentation purposes, and the information you get from vRealize Network Insight enables you to identify your application boundaries and to create the recommended firewall rules, because vRealize Network Insight learns about the different flows in your environment, and from that information it can give you a list of recommended firewall rules if you want to microsegment, let's say on an application basis, or even more detailed at the individual VM level. But let's just focus on microsegmentation at the application level. So that was the initial use case that we had for vRealize Network Insight, and how most customers got to know about vRealize Network Insight. Fast forward to VMware Cloud and AWS, or just migrating applications from VLAN-backed networks to NSX overlay networks, or from on-premises VLAN-backed environments to VMware Cloud and AWS overlay networks. So we use the same mechanism in vRealize Network Insight, the ability to identify application boundaries and inter-VM dependencies, and we use that to determine which applications should be migrated together or which applications can be migrated independently of one another, and so on. So we're not only using vRealize Network Insight for micro-segmentation purposes, but also to identify flows between applications and the magnitude of those flows, because when migrating applications to, for instance, a public cloud data center, you are pretty interested in knowing how much egress network traffic will I get if I migrate this application to a public cloud data center, and so on. That's a financial thing we need to consider. So let's take a look at vRealize Network Insight. So inside vRealize Network Insight, I have predefined the customer database application. So I've statically added the appropriate VMs because I know those 5 VMs. They are the VMs that this application consists of. So if we take a look at this application, and we can already see that vRealize Network Insight has identified a number of flows between the individual VMs and between some physical or external dependencies. So let's take a look at the flows from web to application layer. So you can see there are 3 flows to the application server. Those 3 flows are, funny enough, from the 3 different web front ends. Remember, I have this script running that does curl against web 01A, 02A, 03A, and so on. So that's pretty much as expected. You can also see that we have on port 3306, we have the application server communicating with the database server. And we can also see that we have a number of flows that uses some shared physical infrastructure, which is in this case DNS and name resolution. So we have now identified our application and potential dependencies of this application. And at some point in time, we would like to migrate this application to VMware Cloud and AWS. And to help us in performing this migration, we use HCX, which is which comes with the VMware Cloud and AWS subscription. So now that we have the application identified in vRealize Network Insight, I haven't configured this fling here, but there is a fling available that takes the application definitions out of vRealize Network Insight and injects them into HCX as mobility groups. Like I said, I haven't done that in this environment. It's a fling. Hopefully at some point in time it will be a product feature, but currently it's a fling, and you can use it if you have a lot of applications there and you don't want to do a manual readout of vRealize Network Insight and configure those same applications in HCX. Then you can use the fling. It's basically PowerShell scripts that pulls the application definitions out of vRNI and injects them into the on-premises HCX connector. It's pretty cool. So what is HCX? So HCX is, you can say, workload mobility tool that we use to migrate workloads across different VMware-based software stacks. Could be right from an old legacy vSphere 5.0 environment to VMware Cloud on AWS SDDC, to VMware technology running with other hyperscalers such as Microsoft or Google, or to any VMware-based environment that's based on Cloud Foundation and runs in the data centers of some of our partners like IBM and Fujitsu, OVH, and so on. We also have customers that use HCX to do internal migrations between a legacy environment and a new modern software-defined data center. So the architecture of HCX is that in the on-premises environment, you deploy an HCX connector. It's just an OVA that you deploy. And on the cloud side, for instance, in this case with VMware Cloud and AWS, as soon as you enable HCX, the HCX Cloud Manager is automatically being deployed. Then you set up an HCX site pairing between the connector and the Cloud Manager, and you deploy what we call a service mesh. Service mesh contains a number of migration features, so to say, and those features or those appliances that implement these different features, they are always deployed in pairs. So in this case, we have the HCX IX, the interconnect appliance that they establish between those two applications. They establish a migration tunnel. We also have the network extension appliances. They establish their own tunnel as well to be used for layer 2 extension of on-premises networks to VMware Cloud and AWS. So let's take a look at how we can use HCX to extend an on-premises VLAN-backed distributed port group to VMware Cloud and AWS. So as you just saw here in this small animation, what we want to do now is take the on-premises segment, the HCX migration segment, and extend that to VMware Cloud and AWS. As you can see on the schematics here, the layer 2 extended HCX migration segment in VMware Cloud and AWS is not connected to the compute gateway. So it is literally an extension of an on-premises VLAN-backed port group or NSXT-backed port group. In this case, it can be both. It doesn't really matter. You don't need to have NSX in the on-premises environment. As long as you have VLAN-backed port group on a distributed switch or NSXV or NSXT, then you're good to go with network layer 2 extension. So now I want to show you what it looks like when we actually go into our demo environment and extend the on-premises HCX migration segment to VMware Cloud and AWS. So first, I'll just show you very quickly a tour around HCX. We have the on-premises environment in Copenhagen, and we have the VMware Cloud and AWS SDDC in London. I have already pre-created the site pairing between the HCX connector in the on-premises environment and the HCX Cloud Manager running in the AWS data center in London. And I have deployed what we call a service mesh with a number of services enabled. Before I could do that, I had to pre-create some network profiles. It's essentially creating profiles and reserve IP addresses to be used for the HCX appliances. I also need to create a compute profile that basically tells HCX where to deploy its appliances. So those appliances have been deployed here because I pre-created the service mesh, and you can see that there's the interconnect appliance, there's the network extension appliance, as well as the WAN optimization appliance and the HCX connector itself. You can also see there's we can call it a dummy ESXi host. It's what we call a mobility agent. This is actually the same as the interconnect appliance, and it's act as a vMotion target so that we can tunnel the vMotion traffic to VMware Cloud and AWS and thereby make live migration possibility. So now we want to extend the HCX migration segment from on-premises to VMware Cloud and AWS, and in order to do that I need to configure the IP address of the default gateway of that segment, as well as the subnet size. In this case, I don't use mobility optimized networking. I just run it as a plain and simple layer 2 extension with no compute gateway connectivity on the cloud side. So now that the layer 2 extension has started, let's take a quick look at the vCenter running in VMware Cloud and AWS, and you can see there's already a segment that has been created called L2E HCX migration, so the layer 2 extension of the HCX migration network. And you can also see it here in the Cloud Console or the NSXT interface of VMware Cloud and AWS, that the port group has been created as a disconnected port group. So disconnected port group, here you can see it's only connected to the layer 2 extension appliance itself. So a disconnected port group just means that it's not connected to the compute gateway. And that matches the schematics you saw before. So what we have done now is we have extended the on-premises HCX migration segment to VMware Cloud and AWS through the 2 network extension appliances, and we have not connected the NSXT segment on the cloud side to the compute gateway. So let's go and take a look at how we now can migrate the service itself. So as you can see here, I have now moved the 5 VMs to the layer 2 extent. So network communication wise, they are still attached to a subnet that routing wise exists in the on-premises environment, but they are physically located in the VMware Cloud and AWS SDDC in London. So we haven't changed any IP addresses or anything. We've just migrated the VMs to a different data center. Let's take a look at that. So I'm just telling you that a migration, even though they are small VMs, it does take a little while, and it would be too much to see that in real time here. So I have fast forwarded where applicable. So let me create my mobility group by selecting my five VMs, my web servers, my database servers, and my application server, and add those. Then I need to select where to place my VMs. So in the light green area, the selections I make there will be default for all the VMs below. You can go to the individual VMs and customize the settings for those VMs if needed, if you want them to end up in different folders and so on. So I select my compute resources, storage container, VMDK format, and migration type. In this case, I will do what we call my replication assisted vMotion. So that starts out as a parallel replication of VMDK files and ends off with a number of serial vMotions. So let's validate that those VMs can actually be successfully migrated, and that should be yes to that, and we're good to go for the migration. So what we will see now is 5 parallel replications starting up, and you can see now that I fast forwarded, 4 of them are parked because now we have reached the point where we need to start the vMotion operations. So we have done 5 parallel disk replications, and now we do a number of serial vMotion operations. So now the first VM has been vMotioned from the on-premises environment to VMware Cloud and AWS. And you can see that by switching to the vCenter in VMware Cloud and AWS, we now have a single web front-end server running there. And then the following 4 VMs will be migrated over as well. And in this case, we'll typically lose between 1 and 3 pings in these migration vMotion operations. So now we have all 5 VMs running on the layer 2 extended network. So that's all good, or is it? Because they are still attached to a network that belongs to the on-premises environment. And in this case, I only had these 5 VMs attached to my network. So why not migrate the entire network, the entire subnet from the on-premises environment to VMware Cloud and AWS? So I realized that that's not always an option. So in my opinion, you have 3 options when you're doing cloud migrations like this. You can migrate on a per subnet basis. You can live with permanent layer 2 extensions. So some VMs are running in the cloud and some VMs or physical servers are running on the same network in the on-premises environment. Or you can migrate your VMs and then change their IP address to a new subnet. You can't have it all. You can't have all the benefits. So you need to select which option is most suitable for your specific use case. But in my case, I could migrate all the content off my on-premises network segment. And now I would like to make that a cloud-native network segment, so to say. So now I want to unextend the on-prem network segment. I want to connect the extended network segment to the compute gateway in VMware Cloud and AWS. And then I want to delete the old network segment in the on-premises environment. So let's take a look at that. So now you can see here that I'm attaching the extended network segment to the compute gateway. And now I have done a full migration to VMware Cloud and AWS of my 3-tier application, the 5 VMs that builds my 3-tier application. So let's take a look at that. So I did my network extension here just before, and now I'm going to select this network extension. I'm going to select to unextend that network. And it takes only a few seconds to unextend the network, and all of a sudden I have no extended networks in my environment. So if we switch to VMware Cloud and AWS, you can see that the extent is still there. It's just not connected to the on-premises environment through the network extension appliances. And you can see I get no reply from my curls that calls my web servers. So now I change the extended network segment from a disconnected segment to a rooted segment, which means that I will connect it to the compute gateway like you saw just before on the schematics. And then I return to the on-premises environment and I find my HCX migration segment and I delete that segment. So now I'm in a state where the network segment doesn't exist in the on-premises environment anymore. It's connected to the compute gateway on the cloud side. And then when this network segment has been moved like that or migrated, I need to update the routing between the on-premises and the cloud-based environment so we can get in touch with the application again. I also need to allow access to the application through the firewalls in VMware Cloud and AWS. Let's take a look. Optimally, I would have preferred to have what we call a route-based VPN. That's an IPsec VPN with BGP peering running inside it, because then when I delete a network segment in the on-premises environment, I create a network segment attached to the compute gateway on the cloud side, the routing infrastructure will be automatically updated. But that's not the case. Unfortunately, in my demo environment, I have a plain policy-based IPsec VPN, which means that I need to do some manual updating of the routing. So I paused the recording when I created this demo, and I updated the physical router, the NSX T0 router in the on-premises environment, and I updated the configuration of the VPN connections in the environment. So that kind of mimics what BGP would have done automatically for me. And then let's complete this migration by allowing traffic to the segment that I have on my compute gateway now. So I have pre-created a couple of groups, inventory groups, before I recorded this demo. So I created a group that contains the IP sets of my on-premises environment, just in order to easing up the demo recording a little bit, shorten down the time needed. And I created a group that contains the IP set of my destination, so my compute gateway attached segment. So now I have created a firewall that allows for inbound traffic to my newly connected segment. And as you can see, my VM starts to reply on ping, and I can get data out of my web front ends. And finally, let's see if the application works, and voila, it does. So this was a fairly quick example. Unfortunately, I only have like half an hour for this presentation, but it was a fairly quick example of how you can utilize HCX and vRealize Network Insight to identify and migrate applications between different VMware-based environments. So now my application runs in VMware Cloud and AWS. And what could be next here in my application modernization journey or my cloud journey as such? Well, one slide to put it simple. As you saw on the different schematics, a part of the architecture in VMware Cloud and AWS is that it's network-wise attached to your customer-owned VPCs in native AWS. And Amazon, as you know, AWS, they have 170 plus services that you could utilize and benefit from in order to modernize your applications or cost optimize your cloud environments. It could be in the case of my 3-tier application here, maybe I don't want to run and manage my own database. Maybe I just want to consume that as a service. RDS, Relational Database Service from AWS, could contain my data, so I could simplify my 3-tier application. Could also be that I have a lot of fairly rarely accessed data or file service or whatever that contains a lot of data that are not accessed continuously, and I don't want to keep that data on the SSD-based vSAN in the VMware Cloud and AWS SDDC. So I could move those data taking up a lot of vSAN space and move that to a cheaper file share service in native AWS. So there are plenty of options for continuing to optimize on your application architecture and your infrastructure architecture by starting to adopt cloud native services. So that's all for me. Thank you for listening in, and let's continue with this vForum session.
Thank you, Henrik. That was quite a lot of information you managed to show in just 30 minutes. And now we have a short video from one of our customers, Schibsted, which I know you have already also been involved with, Henrik.
Yes, Tom, that's right. I've been working with Schibsted in Norway for a while. Schibsted were in a situation where they had 2 physical data centers. Actually, there was a number of appealing reasons for migrating to VMware Cloud and AWS. Another one being that they, in a different part of the business, were also consuming a lot of cloud native services. But back to the 2 on-premises data centers, they wanted to reduce that from running 2 data centers to running 1, and then migrate select applications to VMware Cloud and AWS for some financial reasons, some operational reasons, but also for getting some of their applications in close proximity to the cloud native services that they already use and are planning to use increasingly over the years to come. So let's see what Ken from Schibsted has to say. Run the video, please.
On a cloudy day in Oslo 1839, Christian Schibsted decided to stop waiting for others to make things happen. What started as a small printing shop soon turned into a newspaper, Aftenposten, which he set up not only as a business venture, but also to make a statement for democracy and free speech. a rather bold move back then. This move also laid the foundation of Schibsted's ambition of empowering people in their daily lives. And we've been pioneers in this field ever since. Our newspapers have grown into publishing powerhouses and leaders in digital subscriptions. We've revolutionized the classified ads arena, and we've democratized consumer loans and price comparisons, and much more. The list goes on. Today, all of our products, news, marketplaces, and smart digital services have more than 780 million visits per month across a wide variety of brands.
My name is Ken Sivertsen, and I work in Schibsted as a cloud infrastructure architect. Well, first of all, Schibsted is more data-driven as an organization than ever before. Schibsted Enterprise Technology represent innovation at a great scale, and we have a culture for embracing new technologies. We are shifting fast towards native cloud services, enables us with better development speed and time to market. And VMware has provided a great partnership in order for us to keep pace with innovation, making us ready with both efficiency and flexibility. Schibsted has been a VMware customer for decades, and when having VMs in our source environment, the most natural next step for us is VMware Cloud. This enables us with flexible, service-oriented architecture alongside with the cloud-native offerings, and that is just an elastic network interface away. The solution for the Norwegian back-office data centers is VMware Cloud on AWS. This was achieved in great cooperation with both VMware Professional Services and IBM. Beyond the solution itself, we are also utilizing vRealize with Network Insight and Operations Manager. These are quite powerful tools, and in combination, these are bringing great value to our project. Well, thank you for all the insights, and thank you for having me.
Great. That was great. We now move into the panel discussion, and we will be joined by our colleagues, Camilla and Rasmus, and we also have Simon Todd joining us from Intel. So let's bring on the panel. Hi guys, welcome all. And Rasmus, I know you've been collecting and looking at the Q&A during the session until now, and you hopefully have something we can begin with.
Yeah, luckily we had a few things coming in, so I tried to build a few common themes around it. So I think the first one we're seeing, Thomas, is actually probably one for you.
Okay.
Because we are in the video, or in the demo that Henrik had, we were showing a lot around the on-prem cloud foundation and how we are connecting to the VMware cloud solution. But could you elaborate a bit on the building blocks in these two solutions? Just the differences and commonalities.
Okay. Yeah, so the funny thing is actually not that different because it's all based on Cloud Foundation. And Cloud Foundation is our soft bundle of the vSphere platform with vSAN and NSX together. So that bundle of software is basically foundation in both camps, so to say. So the differences are basically on the way it's being operated on the back end, you could say, on the hardware differences and stuff like that. But from a platform perspective, it's the same, and that's one of the beauties of that.
Okay, got it. We have a question, and that's probably to you, Henrik, around the different hosts we can actually consume in the VMware Cloud solution. Could you shortly elaborate on which options we have there?
Yeah, sure. Currently with VMware Cloud and AWS, we have two different instance types, or AWS bare metal instance types. The first one we have, the default one, you can say, is what we call the i3 .metal. It has 2 times 18 cores and half a terabyte of memory and 10 terabyte raw storage capacity, all based on NVMe flash for vSAN to consume. The newer host type is i3EN. It's a 2-socket like the basic i3, but it has 2 times 24 cores. It has hyperthreading enabled in contrast to the i3. It has 3/4 of a terabyte of memory, but most important, it has 4.5 times as much raw storage capacity. So if thinking about balancing compute and storage, it's much more dense can manage more storage dense workloads like databases and so on.
Okay, thank you. Brilliant. Actually, moving on to a bit of the theme when it comes to requirements. This one is also for you, Henrik, because we are talking about quite a few different solutions into the bundle here. Could you just elaborate on the requirements, both from a source on-prem and destination perspective? Is it required to have a full cloud foundation stack to engage in this journey?
No. So first of all, VMware Cloud and AWS, I mean, you can stand that up as a standalone SDDC without having connection to any on-premises environment if you wanted to. But if you're talking about the kind of hybrid setup that I showed during the demo, all you really need is vSphere. And if you want to do layer 2 extension of on-premises networks like I did, again, you would need the distributed switch, so a port group on a distributed switch or NSX. It's not a must to have NSX in the source environment. You must have NSX in the destination environment, but with VMware Cloud and AWS, that's kind of a given. But if you're using HCX on-prem to on-prem between, like, let's say, a legacy environment to a new, more VVD-like based environment, you must have NSX on the destination. So did that answer the question?
Yes, perfect. Thank you so much. I think the next one is probably for you, Camilla. It's a more generic question, actually. So why would you as a customer go for a VMware Cloud solution rather than one of the solutions offered by the native hyperscalers?
Yes, well, there are several use cases, but a quick response would be, like Henrik said before, if you have vSphere workloads and you want to move to cloud quickly and efficiently, then VMC is relevant. And one of the reasons is because first, you don't have to rewrite or refactor your workloads, and it creates this perfect hybrid setup between your on-prem and cloud. And we can extend that so that you have the scalability and flexibility that you expect to get from cloud. But of course, you can also just spin up your own VPTC SDDC separately. But you can continue to use the same tools and operational processes that you have today. So VMC is basically the VMware platform on top of the AWS bare metal. And also, if you only have vSphere today, then with VMC, you suddenly also have the full VCF stack available to you, which is, vSAN, NSX, HCX, and so on. And also you can integrate into the cloud native services with low latency and bandwidth. So those are some of the capabilities that you will benefit from.
Brilliant. Thank you, Camilla. The next one is for you, Simon. So we saw Intel as a sponsor. What role does the Intel hardware stack play in a company's journey towards multi-cloud? Could you elaborate a bit on that?
Yeah, that's actually a good question, that, Rasmus. So there is a close collaboration between Intel and VMware in development of both sets of products. But if you look at it from a hybrid cloud perspective, those 3 elements that have been mentioned, the compute, the storage, and the network, Intel's really uniquely placed there to play a part in each of those 3 pillars. So from a compute perspective, it's CPU and things like persistent memory. Then in the storage, you've got Optane SSDs, and then also in the networking, you've got the 700 and 800 series network adapters. So it plays a part in all 3 elements.
Brilliant. Thank you so much. I think this is probably going to be the last one, and I'll hand it back to you, Henrik. So the whole process here, it looked relatively easy in the demo you just did, although it was very condensed with a lot of information. And also knowing it's not an exact science, but how difficult is it actually to get going here?
So technically, I mean, it's well-known components that we're using, right, based on Cloud Foundation and with HCX and so on. So technically, standing up the environment, establish a migration bridge using HCX and maybe a VPN connection, it's not hard. It's fully automated. The pilots I've been involved with, we've been able to migrate the first VM in between 1 and 3 days. And the space between 1 and 3 days is due to how long time does it take a customer to have outbound firewall ports opened or establish the VPN or deployed appliances and so on. The harder part will be when you start migrating applications for real, where you need tools like vRealize Network Insight that I showed you, because that's where you need to have some knowledge about your application landscape and be very thorough in defining those application boundaries. So that's probably what will take the most time. Not the technical side is pretty straightforward.
Good. So basically what you're saying is that it's like everything else with cloud, it's has a lot to do with the people process aspect as well.
Yeah, and a bit networking.
Good. Brilliant. Knowing that we are coming to the top of the hour, I think we will wrap up now. I want to thank everybody who participated in the webinar today. If there's anything you need to sort of read up on, remember that we will be recording it and sending out a link afterwards. So thank you to all participants, and thank you so much for having hosted the presentation today, Henrik and Thomas, and thank you Simon and Camilla for all the good answers, answers to the questions. With that, over to you, Joe.